So the second part of this measurement lesson is on using a graduated cylinder. Here's a graduated cylinder, at least a sketch of one. And when I put a liquid in there, and there's a liquid and you can see it going up, what do we say for measurement? Actually, before we make that measurement, let me point something out to you. And that is that the liquid kind of curls up on the sides. That's because water, and we usually measure out water or solutions in which water is a solvent in graduated cylinders. Water is rather attracted to glass. So it tends to pull up on the sides as it attracts to that glass and create something called a meniscus. This little curved area here is a meniscus. What part of that do we read from? Yeah, that's a good question. You might think of the top of the meniscus, but we actually always read from the bottom of the meniscus. Okay? And you're thinking that's not quite fair. You know, you're leaving out some of the liquid there, but that's not true, because the bottom of the graduated cylinder, if you look at it down there, actually has that same curvature as the liquid would have in there. So reading from the bottom of the meniscus works out just fine. The curvature of the bottom matches the curvature of the top, so reading from the bottom of the bottom of the meniscus is exactly what you want to do. Another thing you want to do, sometimes it's hard to see exactly where the meniscus is, so you put like a black strip behind it, and then you're going to raise it up so it's just below the meniscus. And when you do that, the meniscus kind of reflects that black band and gives you a much more precise bottom of the meniscus. And there's what that looks like zoomed in. Okay? Another thing you always want to do, make sure to get eye level. Okay? If you read it from too high or too low, there's a phenomenon called parallax. Things aren't always quite what they look like from different angles, different perspectives. Your best perspective for any measurement, where a scale is in front of or behind what it is you're measuring, that often happens with rulers, with graduated cylinders, make sure your eye is perpendicular to the scale. So in this case, get eye level. It's also important to have your graduated cylinder on a level surface, not like a tilted desktop or something like that, but that should be kind of obvious. But then get your eye down level to it. And when you do, remember, read the scale, 1 digit past what's incremented to. That's what we learned in the first one. Because this is incremented every 1 milliliter, we should be reading to the tens place. And don't forget to put the unit on there. Right? That was our first rule. So maybe we're thinking 34.6 milliliters. Okay? Let's try a few more of these. There's a liquid that's in a graduated cylinder, and well, let's get a zoom in on that. 28.1, 28.2 milliliters, something like that. We write down 28.1. It's understood that we're certain of the 2, we're certain of the 8, but don't stop there. Don't just say 28 milliliters. You can go one better, say 28.1. Okay? How about this liquid? Now notice now I'm using a smaller cylinder, and I'm zoomed in on it. So this is 1, 2, 3, 4, 5 milliliters. And when I zoom in on it, it looks like it's right on the mark. Now because this scale is incremented to the tenth of a milliliter, right? Every line there represents a tenth, 3.1, 3.2. We can say 3.7 with certainty, and if it looks like it's right on the line, how do we indicate that? 3.70 milliliters. Okay? If it looks like it's a little bit above it, you could say 3.71. Looks like it's a little bit below it, 3.69. But don't just leave it at 3.7 because it looks like, oh, that's not precise enough. We're certain of the 7 in this case, and we're guessing the 0 in the hundredths place.